Hey guys, welcome to the video tutorial for your free response. In this free response, we're dealing with the resistors in series and in parallel, and then later on we'll be given the task of also having a capacitor in here as well. So first, let's look at this question. Here they're not giving us the resistance values, they're just giving us their ratios and an initial EMF or voltage E. And it says rank the currents in the three resistors from greatest to least, with one being the greatest. If two resistors are the same current, give them the same ranking. Okay, so let's look at this circuit. And here it is. It's kind of small, but it's still there. And if we look at our first circuit here, circuit A, we see that it receives the initial current from the battery. In other words, the total current drawn from this battery. And so that current right here, I'll call it I1, here we've got, in a sense, we've got a junction going on right here. And so that current going in has to equal this current coming out. And so if this is the initial current, then that current gets split between these two resistors. So it should be pretty obvious that RA is my greatest, has the greatest current flowing through it. Now, not an exclamation point, but one. Now, if we look at B and C, B has twice the resistance as C. Now, we know that anything in parallel receives the same amount of voltage. Well, if we go back here, since both of these are receiving the same amount of voltage, well, V equals IR. And so, since RB has twice the resistance of RC, think about the voltage is the same. So if I did I for B, V equals I for B, and it is 2R. So that's V over 2R for the current at B. For the current at C, times just R. So IC is V over R. So we can see that since it has twice the resistance, it's going to have about half as much current flowing through it. And so for this problem, IC is going to be our second largest current, and then following behind would be IB. Now, for the justify your answer, you can utilize the fact that Kirchhoff's rule says, loop rule, says that the current in has to equal the current out, and also state that anything in parallel receives the same amount of voltage, and then go V equals IR, just like I was explaining. Now let's talk about the voltages across the three resistors from greatest to least. Here we're starting out with our initial voltage, and so this battery, or excuse me, this resistor is going to have the greatest amount of voltage flowing through it. And then finally, these two will have equal but less than our initial voltage. And so your ratings here would be 1, and then 2, and then 2. And then for justifying your answer, you could state Kirchhoff's loop rule says that the voltage drops across the entire loop has to be 0. And so if you calculate your equivalent resistance, and then this has the greatest amount of current, which means it also has the greatest amount of voltage, blah, 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 blah. Okay, so now here they tell us that our EMF is 12 volts, and then R is 200. So that means that we're starting out, I'm going to write these over here, E is 12 volts, and then R is 200 ohms. And the first thing they want us to do is calculate our equivalent, or my equivalent resistance for this circuit. Well, RA is in series with these two parallel resistors, RB and RC. And so I'm going to redraw this circuit, but now I'm going to plug in my values for my resistors. And so here I've got 2R, so this is 400. And then here I've got 2R, so it's also 400. And then here I've just got R, so we've got 200. Well, first thing I need to do is combine these two parallel resistors. So REP for the parallel resistors would be 1 over 400 plus 1 over 200. And so solving for that, you get an RP of 133 ohms. And so now this resistor is in series with my first resistor, so R equivalent is just 400 plus 133, 3, or 533 ohms. So that would be part C. Now, let's look at part D. It says calculate the current in resistor RC. Okay, well, to calculate current, we first need to know what the voltage is, because V equals IR. So what we have to know is, okay, what's my voltage drop, because I'm starting out with 12. What's my voltage drop from here to here? That voltage drop plus this voltage drop should give me 12. So I know my R equivalent. So what I need to do is figure out, okay, what's my initial current flowing out of the battery. If I know that, I can calculate what this voltage drop is. And so V equals I'll call it I total because it's the total current drawn from the battery. And that times R equivalent, I can solve for I total. So if I do that, plugging in 12 and then plugging in my come on computer, my R equivalent as 533, I get a total current drawn from the battery of, where did I put that? 0.0225 amps. Okay, so now I can use this resistance and figure out, okay, what's my voltage across this resistor? And then use that to know what's my voltage across these two resistors. And again, we're looking for the voltage across RC, or excuse me, the current across RC. Okay, so first thing I'm going to do is I'm going to solve for, I'll call this V1. Well, V1 is equal to my current across that resistor, which is equal to I total, times this resistance, which is 400. Well, I know I total is 0.0225, and so V1 here is 9 volts, which means that if this voltage drop from, I'll go, this is C to D, this is A to B, I know that VCD has got to be 3 volts because I've got to get back to 12 volts. So now I can use this voltage and this resistance to figure out the current across RC. So I can go VCD equal to I at C times RC. So if I plug in my values, I get a current drawn across that resistor of 0.015 amps. Pretty cool. So let's look at E. E tells us that the switch is open and resistor RB is removed and replaced by a capacitor of a capacitance 2 times 10 to the minus 6 farads, and the switch S is closed again. Calculate the charge on the capacitor after all the currents have reached their final steady state values. Okay, so now instead of RB, we've got a capacitor. So I'm going to go down here and here's our battery, here's our first resistor. Now we've got a capacitor at RB. We still got RC. And we've still got 12 volts, and then 400 and 200. and they tell us that the capacitance here, C, is 2 times 10 to the minus 6 farads. Okay, and they want to know the charge on the capacitor after all the currents. Okay, so the charge on a capacitor, Q equals C V. And so this V is the voltage at that capacitor. Now, it's not the voltage at the battery, but it's the voltage at this capacitor. Now, we solved for VCD before, but that was when this was a resistor. So now we've got a whole new set of voltages across these across these resistors. The voltage at this capacitor is going to equal the voltage right here because these two are in parallel. And so what I need to do is figure out, okay, what's the current being drawn? From that, I can figure out, okay, my voltage drop here and my voltage drop here. Okay, so to figure out my current drawn, I need a new, equal sign. I need a new R equivalent. Well, these two resistors are in series of each other, so R equivalent is just 600. So, solving for my current drawn, I've got I total times 600 gives me a current drawn from the battery of 0.02 amps. So now I can use that and figure out, okay, what's my voltage drop across A, B, and then I can use that to figure out my voltage drop across C, D. So VAB is going to equal my total current, which is 0.02, times my resistance, which is 400. And so I get a VAB of, let's see, that would be 0.02, where is my calculadora? Times 400, looks like it's going to be 8 volts. Which means that VCD has got to equal 4 volts. So now I can use that voltage and this capacitance to get my charge. So if I plug in those values, I get 8 times 10 to the minus 6, and the units on charge are coulombs. So that is a free response for you dealing with circuits.